What's going on, guys, and welcome back to a brand new video. This is Web Dev Journey, and today we're going to be talking about what happens when a service, we can't actually grab a service, that little part right there, right? We don't want our application to drop or crash, so we need to fix that. So for just an example, in my right here, in the speaker service, what I did was just commented out this return res.json, and this is going to create an error where we hang. So let's try it out. So this works just fine. I'll go to speakers, all speakers. This is where it's going to start hanging. And this is going to be a problem because, well, obviously, if we let it hang for too long, it's going to crash our application. Or let's say that tons of users are trying to grab that service. Well, it's going to use up our resources and eventually just crash. And we don't want this to happen. So how do we fix it? Well, we're going to be implementing something called a circuit breaker. And don't worry, we're going to understand how circuit breakers works and what are they, okay? So thank God for Google, we found a diagram, and I'm just letting you know right here. Client, circuit breaker, and this is a service. It doesn't matter what service, but this is a specific service, okay? So a circuit breaker has three states: a closed state, an open state, and a half open state. And we're going to talk about those right now. So a closed state means that the client could actually get all the way to the service and then it comes back. By the way, the circuit breaker is the one making all the calls to the service now. The client is going to make a call to the circuit breaker for a specific service, and then the circuit breaker is going to call that specific service over here, and then it goes back around, right? So closed means client could actually go all the way to service or could reach all the way to service and then it comes back around, right? So it's a closed circuit, right? It's just a closed loop. An open circuit means that from client, we call the circuit breaker and it immediately comes back to the client. We never have a line or we could never request to the service. We could never make a request all the way to the service. It literally just goes to client and then comes back. And then we'll talk about half open in a bit because that one's just a combination of these two. So let's talk about how it works, okay? Here's another diagram. So let's say we have a request and our initial state is always going to be a open or a closed state, sorry. It's always going to be a closed state. So we make a request, and since our state is closed, that's good. Let's say that we have a success and it's always going to be closed, obviously, if it's always a success. But with this closed, we also have a threshold of X number of attempts we could make to actually grab that service. So let's say that our threshold is 5 attempts, right? So let's say that we tried 5 times to grab that service and it does not want to work, or it's not giving us that service. What happens now is that since we reached our threshold, we're going to go to the open state. Okay? And in this open state, we have a cooldown period. And let's say that it's 10 seconds, right? So it's 10 seconds, our cooldown period. Within those 10 seconds, all requests are now going to just fail fast, meaning that we're not even going to try to do anything. We're going to just send you an error right away. You're going to get an error message right away. It's going to be quick. Because we're not doing nothing, right? It's just waiting 10 seconds before we could actually make another call. So within those 10 seconds, you're always going to get an error. Now let's say those 10 seconds pass. Now we go to the half open state where we only get one attempt to actually make a successful request, or just to make a request. All right, just one attempt. So let's say that attempt succeeds. Well, we go back to the closed state and there we go. Now let's say that attempt fails. Well, we now go back to the open state where we got another cooldown of 10 seconds. Okay, so this is how a circuit breaker works, and we're going to be implementing this in our application so that way we could keep track of everything what's happening and never crash our application. Okay, so let's do that right now. And like I said, this is going to be somewhat this part of it is going to be complicated, like I said in the last video. All right, so there's actually several things you could do with circuit breaker. You could incorporate it inside the art meetup in their main application, which we're going to be doing, but some people actually like doing it in the service registry level, and some people actually just try to make it its own service. It really just depends on the use case and really your preferences. In this case, like I said, we're going to be doing it in the main application. So inside of here, inside of server, I'm gonna create a new folder. I'm gonna call it lib, and inside lib, we're creating a new file, circuit breaker.js. Okay, .js. There we go. So, like I said, like I've always been saying, our circuit breaker is the middleman. So this is going to be making all the calls to the service. So we do need to grab Axios. Let's go and equal require Axios. And now let's create our little circuit breaker class. Circuit breaker. I don't know why I said equals. And before I forget, I'm gonna just module dot exports circuit breaker. All right. So don't worry, we're gonna take baby steps from here on out, so that way you understand what exactly is going on. So we are going to have a constructor because we do need to initialize some things right off the bat. So this dot states is going to hold all of the endpoints, or all of the endpoints that we're trying to grab, that we're using, right? And it's going to keep track of those endpoints and how many failures or what state they're in, open, close, half, whatever, right? So this is just keeping track of all the endpoints that we needed or we're using, right? And all of the properties that has in it, meaning if it's circuit, what circuit it is, and all that stuff, right? Next is this dot failure threshold. And like I said, this is just the number of tenths before we actually go to the open state. And then this dot cooldown period. And for right now, I'm gonna just make it 10 seconds. And then this dot request time out. It's going to equal 1 second. So this request timeout is basically how long a request should take. And I'm just saying it should take no more than 1 second. If it's more than 1 second, we're going to consider it as a failure, right? So we're going to increment this by 1. Okay, anyways, here we go. So the first thing we're going to be doing is focusing on this bit right here, this close section, right? So we do, like I said, this is going to be in our initial state. So let's create a method for initial, or I'm going to say init state. And passing in the end point. And let's add this endpoint to the state. So this dot states, giving it that end point. And we're also going to make an object and set properties for that endpoint. Remember, every endpoint is going to have properties of the number of attempts, the failures, the cooldown period, what circuit it's in, what state it's in. So failures, we're going to set that for right now. Since this is the initial state, it doesn't have any failures. Cooldown period is going to equal this dot cooldown period. Nothing too exciting there. Our circuit state. So I'm just say circuit is going to be for right now closed, obviously. And then next try is 0 seconds, because we could try it right off the bat, right? There's no need to wait because this is a closed, so we could just keep on trying. So this is our initial state, which is our initial state. It's closed. We don't have no failures. Our cooldown is 10 seconds if we ever do need that, and our next try is 0 seconds. Now we're going to be focusing now on this part right here, the fail. We're still in a closed state, so we still need to check if it fails, right? If a request actually fails. So let's do that. Let's go back over here, and right above it, so right here, I'm gonna just call it on failure with that end point. First thing we need to do is grab the state. So const state is going to equal this dot state endpoint. So now we have all of these properties inside this state, okay? So we're going to say if it fails, obviously we want to increment the failure. So state dot failures. We're just going to increment that by 1. And then we do need to check if it surpassed our threshold. So if state dot failures is greater than this dot failure threshold, well, what we're going to be doing is saying state dot circuit. We're going to now set this equal circuit. We're going to set this equal to open. Now it's in the open, right, state. And we're also going to set the next try. So state dot next try. We're going to set that equal to new date divided by 1000 to get the seconds and Unix stamp. What? So we could get seconds, and then we're going to just add this dot cooldown, so we could try in 10 seconds from now. And simply console.log, and I just want to alert them. So alert circuit for and point is in state open. All right, we're basically done for this. So on failure, if it's more than, we already have our open state right here, we're going down to our open state. If it reaches our threshold, if it doesn't, all we're going to be doing is just incrementing failures by 1. So we have that. Now what we need to do is say if it's on success, meaning that everything was okay. Well, what we want to do is end point is just set this dot init state end point. We're going to just reset that endpoint to our init, right? Failure 0 and all that stuff. Now what I want to do is actually make another method. And I'm going to do that down here. And I'm going to say can request end point. So this is going to check if we could actually make a request to the service. All right. So we're going to check if we're in the closed state, or if we're in the open state, or what state are we in, half, open, closed, whatever. And just check if we could make a request. So like always, we do need to grab the state, so that way we can start checking properties off of that. Damn it. Copy, paste. All right. First off, I'm going to say if state dot circuit equals closed, what we want to do is return true. Yes, we can make a request to that endpoint. Else, well, we're not going to put else, but now what we want to do is check for the next try. So let's say that we have a next try in here. We should want to make sure that it's past the 10 seconds. If it hasn't passed the 10 seconds, then we can't make a request. If it's still within those 10 seconds, we can't make a request. If it passed it, then yes, obviously we can make that request. So I'm going to just create a variable called now, and we're going to just make that equal to new date divided by 1,000, so we get seconds. And then I'm going to say if state.nextTry is less than or equal to now. What we want to do is say state.circuit is going to equal, now we're in the half state, so half, and we could return true. Now, if that's not the case, then what we want to do is return false. And no, we cannot make a request. Notice that inside this if statement, we're not real. If it is true, we're not going to reinitialize this state because obviously we only have one attempt to do this. So if it fails, or if it's true, we can make that request. But if that request fails again, it's going to go on failure and it's going to set it to open, which redoes all this again, right? We only want to initialize that state once again if it's on success. Now that we have all this set up, we could actually start using it if we wanted to. If in this case we are. So let's use it. All right. So now, like I said, our circuit breakers are middleman, so we're gonna actually be doing all the calls within the circuit breaker. I mean, you could do it inside the speakers.js if you wanted to, you know, but in this case we're just going to be using it inside the circuit breaker. So I'm just grab this because it's pretty much the same thing. On top, I'm gonna just say async call service with our rec options, and in our rec options we are going to be creating a unique endpoint for this. So const endpoint, and we're going to set this equal to, I'm gonna do rec, or I'm gonna just copy this, rec options dot method. This is going to be the get, post, whatever method, and also copy. I'm gonna do a colon right here and paste it, and I'm gonna do the URL because we do need a unique endpoint, obviously, to keep track right here. We don't want to have same or multiple you know what I'm talking about, right? We just need to have unique endpoints, and this was pretty much unique where we have the method and the URL that we're trying to get, that service that we're trying to get, right? Now for this endpoint, obviously we do need to initialize that endpoint and initialize that state, and we could do that in quite a few places. We could either do it in here or in here, and I'm just going to be doing it in here. So right in the beginning, I'm going to say if there is no this.state endpoint, if there is no endpoint inside of states, or if there is no this specific endpoint instead of states, what we want to do is just this.init state with that endpoint, so that way we have that endpoint initialized. All right, there we go. And now up above right here, we could actually check it. So if this dot can request, if we cannot request the endpoint, we want to return false, basically saying that it's the circuit is open, right? Now if we can, what we want to do is just add some properties inside the rec option, which is our request timeout. So rec options dot timeout we're going to set that equal to this dot request timeout times 1,000, because we just 1,000 milliseconds times 1 is 1 second. Right? I don't even know why I said it. You already know. And then we want to do a try catch block, because if Axios does give us an error, it's going to throw out a error. So we catch that, catch with the error, and we're going to be doing some stuff in there anyways. So first, let's just do our error right now. Get rid of this. So if there is an error, what we want to do is say this dot on failure, and just give it the endpoint and handle it that way. And then we want to return false. Right? That's pretty much it. And then if there is, or we can do it and everything's great, or we're going to try this out. Sorry about that. If now we're trying it out. So const rest, this is pretty much the same exact thing, but we're going to be adding one thing in here, this dot on success, and we're going to throw in that endpoint. All right, control save. Okay, now what I want to do, now that we have everything pretty much handled, where we could actually make the call and then all that stuff, we want to use that circuit breaker inside of the speakers.js. And I don't want to make a global variable or a global variable for circuit breaker. I just don't want to have that. I want each speaker service to have their own proper circuit breaker. So what I'm gonna do here is literally just say const circuit breaker is going to equal require, and then we need to grab that lib / circuit breaker, and then I'm gonna say const circuit breaker is going to equal new circuit breaker. And then pretty much down here, all we need to do in the call service is literally just get rid of this, return circuit breaker dot call service, providing the rec options. That's it. Now to try this out, control save. To try this out, I do want to go back to the circuit breaker and just change the request timeout to 2 seconds, so that way you could actually see it take that long. So let's control save that and let's start it up. I think I have everything started up, and right here I have 3 terminals: my service registry, my art meetup, my main application, and my speaker service. And it looks like everything's working well right here. So let's actually open up and try it out. So we could refresh and this should be working awesome. Where we were having trouble was in the all speakers. So if I go to all speakers, 1, 2, and it looks like it's still hanging, something went wrong. Let me check it out and then I'll get back to you guys. Okay, I figured it out. I misspelled timeout, so make sure you spell that right. It wasn't too bad. My fault. Anyways, look, check it out. Now that we know this works, refresh that, it works. Let's go to the part that it didn't work. So 1, 2, and then there we go. But as you can see, our page still works. All we don't have is our speakers, right? We don't have our speakers. And then let's try to refresh this a couple of times. 1, 2, and there we go. Okay, that's the second attempt. This should be our third. We're gonna keep on doing it until we get the actual, until we're in the the open state. And then there we go. We're in the open state where you see that we just get errors right off the bat. Like there's nothing. And then after 10 seconds pass, there we go. We go in the 1, 2 state, and we're trying to do that. And now we're in the open state again because we just tried it with that one time. It's pretty cool, right? So anyways, you see that it actually does work. We're never going to crash our application like this, which is pretty cool. All right, 1, 2, and then there we go. See that? Oh, amazing, dude. That's why it's such an awesome architecture, this stuff. that was it for this video, guys. I hope you enjoyed it. I hope you learned something, because it was honestly, this part of it was pretty much the best part of it. I like it. I don't know. It's good. Anyways, that was it for this video, guys. We just incorporated a circuit breaker, which was pretty awesome. In the next video, we're going to be talking about cache and how to bridge outages and also caching images. So that's in the next video, guys. Hope you stay tuned. Hope you liked the video. If you did learn something, hit the like button, subscribe, leave a comment down below. And if you wish to support me, please do so on the Patreon page down below in the description. I thank you so much, and I will see you in the next video, guys. Again, thank you for watching my videos. Bye.